Hello, welcome to Chapter 5, Section 7, Transformations of Cubic Functions. So we have transformed absolute value functions and quadratic functions, and now we're going to do the cubic functions. And the cubic functions are only a tiny bit different from quadratic functions, in that instead of the exponent being a 2, it's a 3. And the graph looks different. Instead of the graph being a parabola, right, that's x squared. Our graph is cubic, so it goes like this. That's x cubed. And that's the most basic form. It can do a lot of other things too. But we'll see that when we're getting to the graphing stuff. For now, we're just going to transform. So we're going to do example 1. Now remember, inside horizontal inverse, I high. Inside horizontal inverse, and then the other one is outside vertical, same. So make sure you have that written down so that you don't forget the acronyms to help you graph, or to help you write the transformations. Now we're going to write a function g whose graph is a translation 5 units up. Remember, up is vertical, so it's outside. So when it's vertical, you write the equation first that you start with when we're starting with this one, and then you put the transformation wherever it goes. Because it's 5 units up, it goes in the back. So it's x plus 5 because it's positive, it's going up. It does exactly what you'd expect it to do. For part B, we're doing the same thing, but it's going 6 units down. So because it's down, it's vertical, you write the equation first. It's down, so it's negative, and it goes in the back. When we have something that goes inside, because it's left or right, because that's horizontal, remember, inside horizontal, we do the inverse. So because it says 4 units left, it's actually going to be positive, and it's going to go inside. So instead of writing x cubed, I'm going to write parentheses for x, and then put the cubed, so that I have an inside, so I'm setting it up. Because it's going 4 units to the left, like I said, it's positive, so it's going to be x plus 4. And then for the 1 unit to the right, we're going to do the exact same thing. So it's inside, so we need an inside because it's horizontal. It's to the right, so it's actually going to be negative because we do the inverse, so it's x minus 1. Now let's talk about reflections. Reflections, remember, that's what flips it over the x or the y axis so that it looks a little bit different, right? It's flipping it. And when we do that, if it's in the x-axis, that's vertical, so it goes outside. When it's in the y-axis, it's horizontal, so it goes inside. And remember, you use a negative to indicate that there is a reflection. So for the reflection in the x-axis, it goes outside, so we write x cubed first. We put a negative outside, and we're done. For the reflection in the y-axis, it goes inside, so we need to make an inside. That's cubed, and we put it inside. Now, remember, a negative times a negative times a negative is still negative because it's odd, right? There's an odd number of negatives. So this is actually equivalent to this. So interesting how that happens, right? The reflection in the x-axis ends up looking the same as the reflection in the y-axis. Vertical stretches and shrinks. Now remember, this is where you multiply in front. So it's always multiply in front. Okay, don't forget that. The moving up, down, left, right, that goes in the back, but stretches and shrinks go in the front. Then you have to remember, well, if it's horizontal, where does it go? Inside, which means we have to take this number and flip it. It will become a 1/5. So before we do anything, we need to set it up so that we have an inside, right? It goes in front of x, so we need an x. And like I said, you flip it first. So instead of it being 5, it's 1/5. There's the answer. You don't need to do anything to that at all. For the horizontal shrink by a factor of 1/3, we're going to do the exact same thing, right? It's still horizontal, so we flip it to be a 3. It's going to go on the inside because it's horizontal, so we need an inside cubed. We need an x because it's a stretch or shrink. It goes in front, so it's 3. For vertical, we don't do that, right? We're going to use this exactly as we see it. So because it's vertical, it's going to go outside, which means we need our x cubed first. The 1/4, it just goes out front. That's it. For the vertical stretch of the graph by a factor of 2, again, leave it alone. We need the x cubed, that's the That's what makes whatever we're doing go outside, and we stick the 2 in front. Now we're going to do a combination of all of these transformations. So that means that we're doing more than one at one time. However, we're only going to do them one at a time. So let's start with the first change, which is a horizontal stretch by a factor of 3. We kind of already did this, right? It's horizontal, so it's going inside. It's a stretch by a factor of 3, so we have to do the inverse. So that becomes a 1/3. So that's not what we're using. We're using the 1/3. That's going to go inside, so we need to make an inside, which means that we need an inside, right? There it goes in front because it's a stretch or shrink, and we put 1/3 there. Now it's moving, it's followed by. See this word followed by, this phrase. That's important. You have to do it in the order that you're given. If you don't, you'll get it wrong. So, because it's followed by a translation of 10 units down, we need to write the equation and then put the translation on the outside. So, we have 1/3 x cubed, right? That's what we had. And then because it's 10 units down, it goes on the outside, and it's just minus 10, and it goes in the back because it's a movement up or down. So that's the answer. Another one, vertical shrink. Vertical shrinks don't flip, and it's a vertical shrink by a factor of 1/2. So we write the equation, because it's vertical, we write the equation first. We don't have to set up an inside, it goes outside. The 1/2 goes outside, it goes in the front because it is a shrink, so it'll be 1/2 right there. And that's what we get. But it is followed by a reflection in the x-axis. So because that's followed by a reflection in the x-axis, remember the x-axis means that it goes outside. So we write what we just did again. And then we apply the reflection. Now remember, the reflection is a negative. It goes outside, so it goes in front, and there is the answer.